In this video, we are going to find the Laplace transform of t equals 3t from the first principles. From definition, Laplace transform of a function of t is given by integrating from 0 to infinity e raised to minus s of t f of t dt. Therefore, Laplace transform of t cos of 3t is given by integrating from 0 to infinity e raised to minus of st t cos 3t dt. We can write this integral as integrating from 0 to infinity t e raised to minus st cos of 3t dt. At this point, we need to rely on Euler's formula, which states that e raised to I theta is equivalent to cos of theta plus I sine of theta, and e raised to minus I theta is equivalent to cos of theta minus I sine of theta. We're going to sum the two equations. I sine of theta cancels with negative I sine of theta. We remain with I e raised to I theta plus e raised to minus I theta equals to 2 cos of theta. We divide by 2, both sides. Divide by 2. 2 and 2 cancels. We remain with cos theta is equivalent to e raised to I theta plus e raised to minus I theta all over 2. We're going to compare this to cos 3t in our equation. Therefore, cos 3t is equivalent to e raised to I 3t plus e raised to minus I 3t all over 2. So we replace cos 3t in our equation, cos 3t. Therefore, our equation becomes integrating from 0 to infinity t e raised to minus st into e raised to I 3t plus e raised to minus I 3t all over 2 dt. We're going to take the constant outside the integral sign and we divide our equation into 2. So we're going to have it as a half into integrating from 0 to infinity t e raised to minus st e raised to I 3t dt plus integrating from 0 to infinity t e raised to I minus st e raised to minus I 3t dt. Remember the law of indices, which says that a raised to m multiplied by a raised to n is equivalent to a raised to m plus n. That is, when we multiply any two numbers having the same basis, then we sum the powers. We're going to apply this to our exponentials. So our equation becomes a half into integrating from 0 to infinity t e raised to minus into s minus 3i into t dt. That is part A, plus integrating from 0 to infinity t e raised to minus into s plus 3i t dt. That is part P. So we have an equation with two parts. We have part A and we have part P. So we're going to integrate part A, then we compare to part P. The only difference is the plus sign. Integrating using pi parts formula, integrating u dv is the same as uv minus integrating v du. So t is equivalent to u, and dv is the same as e raised to s minus 3i. Therefore, u equals to t, du dt is the same as 1. It follows, therefore, du equals to dt. And dv is given by e raised to minus into s minus 3i t. For us to obtain v, then we integrate dv. We integrate dv, then we integrate this other part with respect to dt. Right. So our v is equivalent to 1 all over negative into s minus 3i e raised to s minus 3i into t. So we're going to substitute into our equation part A. So it becomes integrating from 0 to infinity t e raised to minus into s minus 3i t dt is given by uv minus integrating v du. So what is our u? So our answer is u equals to t all over v is the same as negative all over s minus 3i e into minus into s minus 3i into t. That's the first part, uv, minus integrating our v, which is the same as 1 all over minus into s minus 3i e into minus s minus 3i into t dt. So we're going to integrate the second time, the second part of our equation, that is the integral sign. So our overall equation or our overall answer is going to be negative t all over s minus 3i e raised to s minus 3i into t. Then we subtract the negative signs, cancels with the negative signs, so we remain with 1 all over s minus 3i into s minus 3i e raised to into s minus 3i into t. So that's our overall answer to part A. We now need to apply the limits, that is from 0 to infinity. From 0 to infinity. But remember, e raised to negative infinity is equivalent to 0, and e raised to 0 is equivalent to 1. Anything raised to 0 equals to 1. So we're going to substitute the first limit, which is infinity, where there is t. So our answer is 0 for the first part. E raised to infinity equals to 0. Our second part also, e raised to infinity equals to 0. Then we subtract when t equals to 0. So the first part of our equation is equivalent to 0, t equals to 0. Then the second part is equivalent to 1 all over s minus 3i into s minus 3i. That is e raised to 0 equals to 1. Okay, correct? So our overall answer, if we open the brackets, is 1 over s minus 3i over s minus 3i. Right. That is part A of our equation. We compare this to part B. The only difference is a plus and a minus sign. So it means part P is given by 1 all over s plus 3i into s plus 3i. Right. We now need to combine the two equations. That is part A and part B. So it's a half into 1 all over s minus 3i into s minus 3i plus part B, which is given by 1 over s plus 3i into s plus 3i. So the LCM of the equation is the product of the two. That is part A and part B. So it's equivalent to a half into the LCM s minus 3i into s minus 3i into s plus 3i into s plus 3i. So considering part A into our LCM, we're going to remain with s plus 3i into s plus 3i plus s minus 3i into s minus 3i. Right. Let us create some space. Correct. Remember, from complex numbers, a plus jb into a minus jb equals to a squared plus b squared. That is multiplying a complex number with its conjugate. So it therefore means s minus 3i into s plus 3i, that is our denominator, is the same as s squared plus 9. So we're going to combine the first two. Then we combine the first one and the last one. So it therefore means our denominator consists of two parts, of two conjugate parts, which is the same as s squared plus 9 into s squared plus 9. So that is our denominator. We have it as a half into, we need to pre-multiply our numerator. Our denominator is s squared plus 9 squared. So we pre-multiply the denominator. So it's going to be s squared plus s 3i plus s 3i plus I squared 9 plus s squared minus s 3i minus s 3i plus I squared 9. I squared 9. Remember, I squared 9 from complex numbers. I squared 9. I squared is given by -1. So it means I squared 9 is the same as -9. We cancel s 3i with s negative 3i. So we remain with a half into s squared plus 9 squared, which is our denominator. Our numerator will be s squared plus s squared, which is 2s squared, minus 18, which is negative 9, negative 9. So our equation becomes a half. We can factor out 2 in our numerator. So we have this 2 into s squared minus 9 all over s squared plus 9 squared. So we can cancel the 2 and the 2. So we remain with our overall answer, which is s squared minus 9 all over s squared plus 9 squared. So this is our overall answer. This is our overall answer, s squared minus 9 over s squared plus 9 squared. Thank you for watching. If you like, leave some likes, subscribe, and share. Thank you.